Hello everyone, this is Torsa. I will start my presentation with the Sharpe ratio of tangency portfolio. Let me start with question 10.1 part A. We are asked to show that the Sharpe ratio of the tangency portfolio is equal to square root of h. The Sharpe ratio measures excess return per unit of risk, and it is defined as expected return minus the risk-free rate divided by standard deviation. From the earlier results, we know that for efficient portfolios parameterized by lambda, the variance and expected return are given by specific formulas. When we substitute this into the Sharpe ratio formula, something interesting happens. The lambda terms cancel out completely. So the Sharpe ratio simplifies to just square root of h. This means that all efficient portfolios in a market with a risk-free asset have the same Sharpe ratio. In particular, the tangency portfolio also has this value, which is square root of h, a maximum Sharpe ratio. Now in part B, we need to prove that the Sharpe ratio is maximized uniquely at the tangency portfolio. First, we observe that it is enough to consider only efficient portfolios. This is because any inefficient portfolio can be dominated by an efficient one with higher return and lower risk. Next, we use parametric expression for expected return and variance in terms of lambda. We then define a function theta of lambda which compares the squared excess return with h time the variance. At the tangency portfolio, this function equals 0 and its first derivative is also 0. Importantly, the second derivative is negative, which means the function is strictly concave. Because of this, the function achieves a unique maximum at lambda star. Therefore, the Sharpe ratio is strictly less square of h for all portfolios except the tangency portfolio. So we conclude that the tangency portfolio uniquely maximizes the Sharpe ratio. In part C, we interpret this result graphically. On the graph, we plot risk on the horizontal axis and expected return on the vertical axis. The efficient frontier for risky asset forms a hyperbola. The risk-free asset is represented by a single point at 0, risk and return r. Now, when we introduce the risk-free asset, the efficient frontier becomes a straight line starting from this point. This line is called the capital market line. The slope of this line is the Sharpe ratio, which we already showed is equal to square root of h. Since the tangency portfolio has the highest Sharpe ratio, this line must touch the hyperbola at a point. That point is the tangency portfolio. So geometrically, the capital market line is tangent to the efficient fund. Now moving to question 10.3 part A. We are asked to minimize the variance of a portfolio subject to achieving at least a target expected return mu. There are two cases. First, if mu is less than or equal to r, then the solution is simple. We invest everything in the risk-free asset. This gives us zero variance, which is the minimum possible. Second, if mu is greater than r, we use the formula for expected return of efficient portfolios. We solve for lambda such that expected return equals mu. This gives us lambda as 2 times mu minus r divided by h. The efficient portfolio corresponding to this lambda is the optimal solution. So the problem reduces to choosing the right efficient. In this slide, we compute the explicit form of portfolio. We start with general formula for efficient portfolios in terms of lambda. Then we substitute the value of lambda that we derived earlier. After simplification, we obtain the final expression for x of mu. This gives both the weight in the risk-free asset and the weights in risky assets. The key behind the proof is contradiction. If there existed another portfolio with the same return but lower variance, then the efficient portfolio would not be optimal, which is not possible. So this confirms that our solution is correct. Finally, in part B, we use Tobin's mutual fund theorem. This theorem states that every efficient portfolio can be written as a combination of two portfolios, the risk-free asset and the tangency portfolio. So we express x of mu as minus theta times the risk free portfolio plus theta times the tangency portfolio. Then we compare the risky part of both expression by equating them. We solve the theta. This gives us theta as mu minus r times a minus rc divided by h. Also, if mu is less than or equal to r, theta becomes 0, meaning we invest fully in the risk-free asset. The interpretation is very important. It tells us that all investors, regardless of their preference, only need to combine these two portfolios. So the entire efficient frontier can be generated using just the risk-free asset and the tangency portfolio. To conclude, we showed that the tangency portfolio plays a central role in portfolio theory. It maximizes the Sharpe ratio and forms the basis of all efficient portfolios when a risk-free asset is available. Thank you.